It says a new game show on TV has 100 boxes numbered 1 to 100 in a row, each box containing one mystery prize. So there are 100 boxes, so there are 100 into 1, 100 prizes. The prizes are items of different types A, B, C in decreasing order of value. So each type of item will have decreasing order of value. The most expensive item is of type A, which is a diamond ring, and there is exactly one of these. You are told that the number of items at least doubles as you move to the next type. For example, there would be at least twice as many items of type B as of type A, which means A is given to be 1, B has to be greater than equal to 2, and then at least twice as many items of type C as of type B, and so on, which means C has to be greater than equal to 4, D has to be greater than equal to 8, and so on. There is no particular order in which the prizes are placed in the boxes. So any type of item can come in any box. What is the minimum possible value of the number of items of different types of prizes that we can have? So we are told that we already have one type of item A and we need 99 more types, 99 more prizes. So we need 99 more items. So we can have a type B which will have 99 items, and we see the condition that B has to be greater than equal to 2. So 99 is greater than 2. So therefore this is correct. So we can have a minimum of 2 types. So minimum type is 2. What is the maximum possible number of different types of prizes? So we found the minimum, we are asked to find the maximum. Now, in order to maximize the number of types of items, we have to minimize the number of items in each type. And let's see how we do that. So we are given that we have one item of type A, and the other types will increase by a factor of 2 at least. So we have type A, B, C, D, E, F, G, H, and so on. So 1 is given for A, B minimum value is 2, C minimum value is 4, D minimum value is 8, E minimum value will be 16, F minimum value will be 32, and if we add all this up, it gives a total of 63. Now G minimum value would be 64, which is double of 32, but if we have 64, then 63 plus 64 is greater than 100, which cannot happen. So therefore 64 cannot happen. So the maximum number of prizes of different types can be 6 only. We move to the next question, which says, which of the following is not possible? So let's see which of the options is not possible. So the first one says there are exactly 60 items of type D. So we know that we can have a maximum of 6 types, and it is given that there are 60 items of type D and one of type A is already given. So that means that the sum of the total number of items of B plus C will be equal to 100 minus 61, which is equal to 39, and this can happen in many ways. One way could be that C is 30 and B is 9, so B is greater than 2, and C is greater than 18 because B is 9 now, and D is greater than equal to 30. So all the conditions are fulfilled here. Or we can also have one more case where we can have B as 10, and that means C would be 29. So again, B is greater than equal to 2, and C is greater than equal to 20 here, and D is greater than equal to 58. So all the conditions are fulfilled, and this can be another way in which this can happen. So this is definitely possible. Let's try the next option, which says there are exactly 30 items of type B. Now 30 items of type B means this is 30, A is given to be 1, and C can be 100 minus 31, which is 69, which is a possible case. So this can be a case where B is 30, C is 69, and A is 1. So B being 30 is possible. So this is also possible. Now let's check option number 3, whether that can happen or not. So option number 3 says there are exactly 45 items of type C. Now A is given to be 1. If C is 45, that means B has to be a maximum of 22 and a minimum of 2. Now if I take B as 22, then the total of A, B and C comes out to be 68, and in order to have a total of 100 prizes, D can take a value of 32, but that is not possible because since C is 45, D has to be at least 90. But if D is 90, then 90 plus 68 is greater than 100, which is not possible. So this is not possible. So in no way we can have the value of C as 45, right? We can also check for B equal to 2, which is the minimum value. So 1, 2, 45 makes 48, and then 52 should be the value of D, but that is not possible because D has to be a minimum of 90. So again, this is not possible. So we can clearly see that for no value of C equal to 45, we can meet the conditions. Not possible. So this is the right answer. And let's check the last option. There are exactly 75 items of type E, which means E is 75, A is given to be 1, B can be 2, C can be 4, and D can be 18. So this is one way in which the total comes up to be 100, and this condition can be fulfilled. So this is possible. So all options except option number 3 is possible. So 3 is the right answer. Let's go to the next question, which says you ask for the type of item in box number 45. Instead of being given a direct answer, you are told that there are 31 items of the same type as in box 45 in boxes 1 to 44, and 43 items of the same type as in box 45 in boxes 46 to 100, which means whatever type of item is there in box 45, we have 31 similar items in boxes 1 to 44 and 43 similar type of items in boxes 46 to 100, and plus X number of items in box number 45. So which means this is whatever type it is greater than equal to 74. So we know that type 1 is type A is 1, and we are asked to find the maximum possible number of different type of items in this case. So we know that 74 is one type of item. So how many different types of items can come in between? So in order to maximize the number of types of items, we have to minimize the number of items in each type. So type B would be 2, type C would be 4, type D would be 8. So this adds up to 89. Now we know that this type is greater than 74, so it can go up. So we have a gap of 11 to make it 100. So we add 11 here, so this makes it 85. So 85, 8, 4, 2 and 1 could be a possibility. So we are getting, so we look at the choices, so we are getting 5 as the number of types, 1, 2, 4, 8 and 85. But if we try to check for 6, so we will have 1, 2, 4, 8 and we have 74 here minimum. So after 8 it will be a minimum of 16. So if I do that, then the total comes out to be 105, which is greater than 100, which is not possible, and therefore this cannot happen. So the maximum possible type of items would be 1, 2, 3, 4 and 5. So 5, which is option number 4 in this case, is the correct answer.